So let us try to evaluate these 5 integrals from where we had left, that is integration by substitution. So for the first one, you start by saying let I is equal to integration of tan inverse x by 1 plus x square dx. Okay, now you know that the derivative of tan inverse x is ddx of tan inverse x is 1 by 1 plus x square. So I say here let t is equal to tan inverse x. Okay, so that means dt dx is 1 by 1 plus x square. That means dt is dx by 1 plus x square. So clearly here if you see this dx by 1 plus x square becomes, this part becomes dt. So you can write this integral as integral. Now also t is tan inverse x, so you can write t for tan inverse x, and dx by 1 plus x square has become dt. So clearly your integration of t dt is half of t square, right? X to the power of n plus 1 by n plus 1 plus a constant, which is equal to half of, now t is, put back the value of t, get tan inverse x whole square plus c. So this is your solution for the first one. Let us see the next one. Let I is equal to integration 1 plus log x whole square divided by x dx. Here again, if you see, the derivative of 1 plus log x, ddx of 1 plus log x is 1 by x. So therefore, what you do is you substitute t is equal to 1 plus log x. You can also substitute log x is equal to t, no problem. Okay. So if you substitute t is equal to 1 plus log x, then what is dt dx? Dt dx is 1 by x dx. 1 by x. Dt dx is 1 by x. That means dt is dx by x. So what do you see? This dx by x part, this part becomes your dt. So what are we left with? Integration 1 plus log x we have taken as t. So this becomes t squared dt. So this becomes 1/3 t cube plus c, which is 1/3. And what is t? T is 1 plus log x whole cube plus c. This is what the second integration. Let's see the third one. Third one is integration e to the power of x by 1 plus x e to the power of x into 1 plus x divided by cos square e to the power of x. Cos square x e to the power of x dx. Now what you must realize here is that the derivative of x e to the power of x is e to the power of x into 1 plus x. That is what you must realize here. And remember, this is a very important derivative also. X e to the power of, that derivative of x e to the power of x is e to the power of x into 1 plus x. So that is why what you do is you substitute t is equal to x e to the power of x. Therefore, what do you get? You get dt dx is equal to x e to the power of x plus e to the power of x. U into v rule. Therefore, you get this as 1 plus x e to the power of x. So what do you get the value of dt? You're getting the value of dt as e to the power of x into 1 plus x dx. Okay. Now
Yes, sir.
our question is answered. Why did we put t is equal to x to the power of x? Because we knew that the derivative is this, which is your numerator. That is why we put. Okay, so now what you do here is this part e to the power of x into 1 plus x dx, this entire part becomes your dt. We write this as dt divided by cos square x e to the power of x is t. Okay, So this is dt by cos squared t. So that means this becomes integration sec squared t dt. And what is the integration of sec square? We know integration of sec square is tan. So tan t plus c. And what is the value of t? Put back the value of t. Value of t is x e to the power of x plus c. Okay.
Okay, sir.
Any question till now? Okay. So 1/4 we have, let I is equal to integral x square tan inverse x cube divided by 1 plus x to the power of 6 dx. Okay, this is your integral. Now there is something that you must realize here. You see that what is the derivative of x cube? What is the ddx of x cube? ddx of
Sir,
x
3x
cube is
square.
3x square. dx. 3x square is the derivative of your x cube. So what you see here
And
is, that you have an x cube here, right? You have an x square here. So you have an x square here also, right? And x to
yes,
the
sir.
power of 6 can be written as x cube whole square, right? So this is
Yes,
the
sir.
main
Yes, sir.
realization that you must have. So what you do here is, first you write this integral as x square tan inverse x cube by 1 plus x cube whole square dx. Okay. Now you put t is equal to x cube, because you know that the ddx of x cube is 3x square. So now you put t is equal to x cubes. Let's see what happens. dt dx becomes 3x square. That means dt is 3x square dx. Now if you see in the numerator, do you have x square dx? Yes, you have. You have an x square here into dx. You have. So both of them will
Yes, sir.
combine to, now if you see here, x square dx can be written as 1/3 dt, right? So if you see both of these, x square and dx here, both will combine to give you a dt, right?
Yes,
So
sir.
what you can write here is integration of tan inverse. Now what is
Yes,
x cube
sir.
we have taken? We have taken t is equal to x cube. You can write tan inverse t divided by 1 plus x cube you have again taken as t. This is x cube whole square. So this becomes t square, and x square dx becomes dt. So everything has been changed to t. Okay. Now what should you do? Now if you again see, this reduces to which form? This reduces to your this form. Okay. Now either from here you can proceed in two ways. Either you can remember this rule which I had mentioned last time also, that any function, integration of the derivative of any function divided by that function dx will always give you the log of the denominator. You can remember this rule. Or what you can do here is, you can again put u is equal to tan inverse t and then proceed. Okay, that means if you are using this, then from here you can directly write this as log of 1 plus t square plus c. Understood?
Yes, sir. Yes, sir.
F dash x, no, this is not f dash x. Wait, this is not this rule, because in the numerator we don't have the derivative of the denominator. In fact, we have, when we integrate the denominator we get the numerator. So what you do is, you proceed in this way, that is, you say let u is equal to 1 plus t square, in fact tan inverse t. Let u is equal to tan inverse t. Okay, so you get du dt is equal to 1 by 1 plus t square. That means du you get as dt by 1 plus t square, just as in the first integral. If you see, we had done. Okay, now dt by 1 plus t square, this part becomes your du, right? So this becomes integral tan inverse t is u, right? And dt by 1 plus t square becomes du. So this is u du. So this is half of u square plus c. Now you put the value. What is the value of u? The value of u here is tan inverse t. You put the value of tan inverse. And what else? What is t here? T here again we had put this as x cube. So this is x cube plus c. Okay. So you can proceed in this way. And the last one.
Okay, sir.
This is now 1 5. Let I is equal to integral x square divided by a plus bx whole square. Now remember, whenever you get this kind of an integral where in the denominator you have where in the denominator you have the degree of the polynomial as equal to the degree of the polynomial in the numerator. Okay, whenever you have this kind of a situation, okay, you can divide directly. How do you divide? But here if you see, this is an a plus bx whole square, you can expand and then divide. Okay, so what you do here is you write this as x square by a square plus b square x square plus twice ab x dx. Okay, now you start dividing. So you have, what is the dividend here? Divisor here, a square plus b square x square plus twice ab x. Okay, and your dividend here is x square. Okay,
Yes, sir.
so how will you divide this? Better way is, if you see, since a and b are unknown constants, okay, this would have worked if we had a and b as numbers, but since a and b are unknown constant, so better still what you do here is you put a plus bx is equal to t. This will work better. Okay, that means you have bx is equal to t minus a. That means x is equal to t minus a by b. Okay, also if you differentiate both sides, what do you get? B is equal to dt dx. If you differentiate both sides with respect to x, that means what are you getting? You're getting dx is equal to dt by b. Now you change everything to t. What is x here? X here is t minus a by b. Put the value of x, you get this. And what is b here in the denominator? What is in the denominator here? You have a plus bx. You put this as this. And what is dx here? You have dt by b. Okay, now everything has been changed in terms of t. Now you can evaluate very easily.
Yes, sir.
Okay, so what you do here is you write this as t minus a whole square by b square t square into dt by b. Okay,
Yes, sir.
now what you do here is you get a b cube. When you multiply, you have t minus a whole square by b cube t square dt. Now what you can do is you can take 1 by b cube out because it is a constant. So you only left with t minus a whole square by t square dt. Now how to evaluate this? Expand t square minus 280 plus a square divided by t square dt. Okay. So now what do you get? 1 by b cube. Separate it, everything. You have integration t square by t square dt minus integration 2at by t square dt plus integration a square by t dt, right? So you get 1 by b cube, and then t square by t square, this is will cancel. You get only integration dt. And what is integration dt? It is simply t. And here you can take 2a out. First t will cancel here, 1t will cancel here. And now you can take 2a out. You'll get integration dt by t. Plus again you can take a square out of the integration because it is a constant, dt by t. Okay. So now finally you have 1 by b cube t minus, what is integration dt by t? It is log t. 2a log t plus this is t square, not t. A square by t square. So this should be t square. And what is the integration dt by t square? It is t to the use your x to the power of n plus 1 by n plus x to the power of n plus 1 by n plus 1. You get t to the power of minus 2 plus 1 by minus 2 plus 1. So this actually becomes a minus. Okay, minus 1 by t plus c. Okay, now you can put the value of t. What is t we had taken? We had taken t to be a plus bx. So put the value of t as a plus bx. So you get 1 by b cube a plus bx minus 2a log a plus bx minus 1 by a plus bx. That's it. This is your solution. This is a required integral. Okay, so whenever you see a whole square in the denominator, even the degrees are equal, but you see there is the power of x is 1 in the denominator here. Okay, so whenever you see a power of 1 in the denominator, you put that entire denominator is equal to t. Okay, that is the main observation that you must make here. Let us try the next set of problems. Let I is equal to integral 1 by e to the power of x minus 1 dx. Now you see, whenever you get an integral of this kind, where the expression does not contain anything apart from e to the power of x, okay, always try to get an e to the power of x in the numerator and denominator. That will be very helpful. If you see in this integral, you have e to the power of x only in the denominator. Okay, we try to bring e to the power of x in the numerator also. How can it be done? What you do here is you write e to the power of x as 1 by e to the power of minus x minus 1, okay, dx. Now if you take the LCM, you get 1 minus e to the power of minus x by e to the power of minus dx. Now this goes to the numerator, it becomes e to the power of minus x by 1 minus e to the power of minus x dx. Okay. Now you see I've got an e to the power of minus x in the numerator as well as the denominator. Now I can
Yes,
do
sir.
some substitution. Okay, now I can do some substitution in order to evaluate this. So I say let t is equal to
Sir.
1 minus e to the power of minus x. Okay, I put the denominator equal to t. Why did I put the denominator equal to t? What I notice here that if I put denominator equal to t and then if I differentiate it, I will get the numerator. See, because if you differentiate dt dx, you're going to get minus of minus e to the power of minus x, which is e to the power of minus x. That means what are you getting here? dt
Yes, sir.
is equal to e to the power of minus x dx. So that makes our task easy. That is why I obtained e to the power of minus x in the numerator also. An exponential function in the numerator as well as in the denominator. So now what you can do here is this e to the power of minus x into dx, this combines to become your dt. So you can write this as dt. And the denominator I had taken as t. So this brings you to only log t plus c.
Okay, sir.
log of 1 minus e to the power of minus x plus c. So this is your answer. Okay.
Thank you,
Let's
sir.
try the next one. Number 2. Let I is equal to integral dx by e to the power of x plus e to the power of minus x. Now again, if you see e to the power of x is only in the denominator. So I try to bring an e to the power of x in the numerator also. How do you do that? E to the power of x, and you change e to the power of minus x to 1 by e to the power of x. Okay, you can change e to the power of x to 1 by e to the power of minus x also, no problem. Same thing. So this
Okay,
becomes
sir. Oh, okay, sir. Okay, sir.
e to the power of x, and this becomes e to the power of x into e to the power of x plus 1, right? Now what is e to the power of x into e to the power of x? This e to the power of x goes on top, becomes e to the
Sir,
power of x,
E2x. Oh,
and this
oh.
becomes e to the power of 2x plus 1 dx. Now we have e to the power of x in the
Okay,
numerator as well as the denominator. What you see here is that e to the power of x in the denominator, e to the power of 2x in the denominator, in fact, can be written as e to the power of x whole square plus 1. Now this becomes a little easy because now you put t is equal to e to the power of x. So what happens? dt dx is e to the power of x. That means dt is e to the power of x dx, right? So therefore this
yes,
integral
sir.
now becomes this entire part e to the power of x dx. This combines to become your dt, and this e to the power of x whole square, we have taken e to the power of x is equal to t, therefore e to the power of x whole square becomes t square. And what is the integration of dt by 1 plus t square? If you remember, it is tan inverse t plus c. Now
Yes,
you
sir.
put back the value tan inverse e to the power of x plus c. That's it. Okay. So let us see the next one. Let us see the next one. That is 1 4. 1 oh 1 3. 1 3 is left. 1 3. So let I is equal 1 3 is very similar to 1 2. Power of 2x. I'll just leave the do half of this and leave it up to you. Okay. So e to the power of 2x. See, in this way is very easy because I have e to the power of x in the numerator as well as the denominator, right? Isn't it? I
Yes, sir.
have
Yes, sir.
in both. Now, what I also know is that e to the power of x, when I differentiate, I get e to the power of x only. So what I do here is I put let t is equal to, this time let us put 1 plus e to the power of x. Okay. You can put e to the power of x also, no problem. Okay. You will get the same thing.
Okay, sir.
That means dt dx you get as e to the power of x. That means dt you get e to the power of x dx. That means now what can you write with this integral? You have e to the power of x whole square, right? You can write this as e to the power of x into e to the power of x dx divided by 1 plus e to the power of x. See, now in this integral, this e to the power of x into dx becomes what? This becomes your dt, right? This one.
Yes, sir.
And t we had taken now, since
Yes,
e to the
sir.
power of x is equal to t, what can I write? I can write t minus 1 is equal to e to the power of x, right? So instead of 1 e to the power of x, you replace by t minus 1 right? And the other, this one, e to the power of x dx, you replace by dt. And denominator, 1 plus e to the power of x is t. So that's it. So what now, if
Yes,
you
sir.
separate, you get t by t dt minus dt by t, right? So now you integrate separately.
Yes.
You simply get integration dt minus integration dt by t, which is t minus log t. Okay, and t we have taken as 1 plus e to the power of x. So 1 plus e to the power of x minus log 1 plus e to the power of x. That's it. Plus a constant of integration, obviously. Okay, so this is your number 3. Let us proceed to number 4. One was root over of 2e to the power of x. Solution 1 4. Now again, if you see in this integral here, e to the power of x plus e to the power of minus x by e to the power of x minus e to the power of minus x dx. Right? Now in this integral, if you see, if you differentiate the denominator, will you get the numerator?
Mm,
If I take t is equal to e to the power of x minus e to the power of minus x, and if you
yes, sir. We
differentiate,
will get it.
yes, you'll get e to the power of x minus e to the power of minus x, which is e to the power of x plus e
Yes,
to the
sir.
power of minus x. So that means, what is your dt? Dt is e to the power of x plus e to the power of minus x dx. So therefore, what is I? E to the power of x plus e to the power of minus x dx will give you a dt. This entire thing will combine, right?
Yes, sir.
To give you a dt. And in the denominator, we had already taken it as t. So this becomes log t plus c. So this is log of, put the back the value of t, e to the power of x plus e to the power of minus x plus c. So this was a simple enough problem. Okay, now let us see the last
Okay,
one.
sir.
And the last one is a little tricky one. Okay, last one is a little tricky one in the sense that your standard substitutions might not work here. Okay, well, let's see what the problem is first. You start by saying let t is equal to integral dx by root 2 e to the power of x minus 1. Okay, this is your given integration. Now, here we have a e to the power of x in the denominator, but the only problem is that this e to the power of x is under a radical. Okay, so if it is under radical, then what should we do?
Yes, sir.
That is the
Mm,
question here. Okay, so what you can do here is you can put t is equal to square root of e to the power of
no,
x minus 1. You put the denominator equal to the square root because there is a square root in the denominator and there is nothing much that you can do. If you put e to the power of x directly, you don't have anything in the numerator also, right? So you put, whenever you see this kind of a situation where you have a radical in the denominator along with some other function, okay, try to put that radical equal to t. So now what do we get here? That means we get t square is equal to 2 e to the power of x minus 1, right? That means now if you differentiate this, what do you get here? If you differentiate implicit functions, remember, you get 2t dt dx is equal to 2 differentiating both sides with respect to x here. Okay, implicit functions, remember,
okay, sir.
twice e to the power of x. This is what we get only. Again, 2 and 2 here cancel from here, right? So what do we essentially get here? What we get here is that dx is equal to dt by e to the power of x. Are we getting or not?
Yes, sir.
But again, we have not changed the entire dx into dt. See, dt by, again you have an x here, right? So what we'll do here is that from here we'll get the value of e to the power of x. So from here, what can we write? Implies we can write e to the power of x is equal to t square plus 1 by 2. So now this changes to dt by t square plus 1 by 2. So this becomes 2 dt by t square plus 1. Okay. So dx, so you have now come to
Yes, sir.
know dx in terms of t, right? And denominator you have already taken as t. So therefore, what does I become? I becomes dx. Put the value of dx. What is the value of dx? It is 2 dt by t square plus 1, right? And
Yes, sir.
denominator you are already taken as t. What happens? This becomes integration of 2 dt by t into t square plus 1, right?
Yes, sir.
Hmm. T square. Hmm. So this t and this t has cancelled. You can take 2 out and you get dt by t square plus 1. And what is the integration of 1 plus x square? It is tan inverse 2 tan inverse t plus c. And put back the value of t. You get 2 tan inverse. The value of t here is root over of twice e to the power of x minus 1 plus c. So that is what we stop here for today.
Okay. Okay.